This is our third video within part 3 of this series, entitled Hummerism Meets Hidden Structures. Now, before we go into this third video, I thought we would just remind you of the two primary performance types for a Hummer routine. The first one is where all of the cards are down facing. The cards of interest are in the even and or odd positions. The other type is where we have some cards face up and some face down. And the goal in the end is to preserve that relative spatial orientation of the cards. Okay. I also have here a full list of the procedural steps you can go through and be successful. There's a couple of important shuffle classes here that I thought we would remind you of. The first one is a PR shuffle. Now, these kinds of shuffles essentially preserve alternating face-up, face-down structures. Okay, and here was the partial list that we gave you, and at some point we actually have used all of these in previous videos. Okay, and then the other one is associated with parity separation. And these are called PRF shuffles. And so these are shuffles that are used at the very end for both types of performances. And it's also used right here in performance 2. Okay? So maybe I'll just give you a moment to look at that and remind yourself this is actually just a picture of the write-up that we showed you in the videos. Okay, so let's go ahead and begin this third video within part 3. Okay, so what we're going to do here is we're going to have two directions that we need to look at. Okay, the first one is we're going to go from a hidden structure type of arrangement and then take it into the world of Hummerism. When we're done with that, we're going to reverse the arrow. We're going to take a Hummer shuffled packet and bring it into the world of hidden structures. Okay? So what I've listed is a kind of classic 2-cycle. Now, what I am assuming here, if you notice, each cycle needs to be an even number of elements. Okay? So that's important for this first statement. Okay, here is a simple example of a 2-cycle in which the cycle length is even. Okay, and the total cycle length is 8 here. Okay, so number 1. Use the hidden structures diagram and property and mixing routines to mix this up, but eventually convert it back to a 2-cycle relative to card value. Now, we're not going to go through and show you all of the, well, we can't. The video will just be too long. Okay, so now it's going to be mirrored. Once it's mirrored, you can do as many LR shuffles as you like. That's great. Okay. We could do 2 identical overcoats. That's 5. Coat 5 again. 1, 2, 3, 4, 5. That preserves mirrored structures as well. We can do an even up jog or an odd up jog. Okay. And why don't we go ahead and do a mange. That takes it back to a 2-cycle of some sort. Okay, there you go. So that's back to a 2-cycle structure. Okay, now perform a Hummer shuffle. Okay, so if you remember, there's a number of ways to do that. If we just do the in hand, it's random cut, flip 2, random cut, flip 2, random cut. I'm not doing a very good job. Flip 2, random cut, Maybe we'll flip 4 this time. If you remember, we can flip any even number. We also have the Hummer table shuffle, where the spectator can freely mix and flip these however they like. If you recall, we can do as many odd coats. You can spell out R-E-D, red, A-N-D, and black, B-L-A-C-K. Those all have even number of letters in them. And of course, at any point, you can flip the packet over and work from the other side. Maybe we'll flip 4 this time. Okay, so that's enough Hummer shuffling for right now. Okay, now perform a PR shuffle. Now this is from the review just a second ago. So we are free to perform any or all of these. Okay, they will not undermine the end result. Okay, I won't take the time to do those right now, but I think if you've watched my previous videos, you know you'll be successful. And then what we need to do is perform one of the parity separation procedures. Okay, and it's any one of these here. Also, I want to point out, I believe it's on the next page, I have these PRF asterisk shuffles. Okay, so these are parity separation procedures that technically don't qualify as a PRF shuffle given the definition. But it is true that all PRF shuffles are parity separation procedures, but not all parity separation procedures are PRF shuffles. Okay, so we've used the folding procedure before, the LR, and then you flip either side. We can do the folding procedure, that would be just fine. So this is where you put them out in 4 piles. Spectators free to flip these however, like from left to right, we can fold these, or right to left, inside out, or outside in. Okay, now what will happen is we will, if we perform these actions, it will result in n pairs. Now n for us is 2, right? So n for us is 2. P-equivalent cards facing one way, and n pairs of p-equivalent cards facing the other way. Okay? Well, all that means is, okay, so let's look at this. So we'll have, so remember, n is 2, right? Because we had 4 and 4. So we'll have 2 pairs of p-equivalent cards. Well, remember, p-equivalent cards are the ones that are in positions that are congruent mod 4, right? So these are these were p-equivalent, and they're also c-equivalent, right? They have the same value. These were p-equivalent and also c-equivalent. Okay, so essentially we have 2 pairs that match. Okay, that's a simpler way to explain it if you don't remember all of the technical vocabulary. And the same thing here. We get 2 2s and 2 3s. Okay, so here is a routine. In fact, it's the very thing that I was just talking about. So start with the 2 cycle relative to card values that add to 14. So the 3, Jack counts as 11. So 3 plus 11 is 14. Now we move 1 over. Queen is a 12, plus 2 is 14. Of course, a couple of 7s added, 14, and so forth. Okay, so this is set up the way it's mentioned there. Now the narrative for this is we're going to find the answer to life, the universe, and everything. Okay, now if you're concerned that the spectator is going to think that these cards are set up, to begin with, you can show them the cards. And I suppose you can tell the little fib that you just happened to grab 12 cards from the deck, and it sure looks that way. If they have any suspicions at all that they're in order, those suspicions will die immediately. Just perform a couple of Charlier shuffles, which you know preserve 2 cycles. Okay, now we are to perform 1 AK shuffle. That's an alternate Klondike. So you Klondike cards, left, right, left, right, left, right, with random stacking, which is wonderful. So you can have the spectator decide right on left. Okay, great, your choice. And now you can do as many LR shuffles as you like. I should point out that the alternate Klondike that we just finished, it moves it from a 2-cycle structure to a mirrored structure. So now the cards are mirrored, so the stay stack principle is in force. So we can go ahead and do as many left-right shuffles as we like and mix those, stack those in any order. We can actually use here we're using the stay stack principle as well. Dealing out 3 piles, you can stack from left to right or right to left. It doesn't actually matter. It preserves the mirrored structure. We could even do 4. Okay, 4 piles, and we can stack from left to right or right to left. Oh, sorry about that. Let's see, what did I do? Oop, this one goes there. Apologize for that. Okay, so left to right or right to left. It will work. I also want to point out that I haven't really shown my students exactly how this works, but I've discovered other stacking procedures, if it's mirrored, that will actually preserve the mirrored structure. This is one right here. Okay, so if you follow that exactly, it actually works just great. So it's mirrored now. We want to take it back to a 2-cycle. Okay. So all of this is just mixing to convince the spectator that in a Charlier that the cards are beyond the knowledge of any human, which is true, which is very much true. I don't know. The only thing I know is this is a 2-cycle. That's all I know. I don't know how the cards are actually arranged relative to each other. So all I know is like this one here. Let's come over here. This one is P-equivalent with that one. They're the first card in their respective cycles. And their values will have to add up to 14. Over here, a couple of 7s, 3 and a jack is 14, and so forth. That's all I know. I couldn't tell you the order. I only know the structure, which, as you can see here, is still a tremendous amount of information. Okay, so now let's go ahead and perform the Hummer mixing. And so that's going to tie in with what we were talking about right at the beginning, right? So we have a 2-cycle in which each cycle, individual cycle, is even. Ours is 6. We have cycle 6, cycle 6. Okay, so we're going to apply this now and then be able to invoke the conclusion there. Okay, so we're going to Hummer shuffle it. Random cut, flip 2. Random cut, flip 2. Random cut, flip 2, and so forth. You can actually put out even packets of cards if you like, and have the spectator decide how to stack or flip as well as you go these piles together. Okay, and so you can do that forever, actually. Okay, now perform, and we can even perform a PR shuffle. Okay, so you really can shuffle this for a very long time, longer than the spectator will have the patience for, but you just kind of judiciously choose 1 or 2 or something. But we can now employ any of these or all of these if we like. That will not undermine the intrinsic quality or characteristics of this Hummer packet. That's the key. Okay? So you can do any of those. And then we need to perform one, and only one, parity separation procedure. So as I mentioned, these are the ones that we've used a lot. There are additional ones here that maybe we can use a different one. Now we can perform any one of these over here that we like, and they will preserve. They serve as a parity separation procedure. So let's go ahead and we'll do this one up here. So it's an up jog, random flip, and then a Klondike. Okay, so you just do an even up jog, or odd actually, it doesn't matter. Okay, so there we go, like this, random flip, like that. Now it is true, technically you're done. You're done. That is a parity separation procedure, right here. See that? But this falls in the classification that it also preserves alternating structures. So it won't actually help or hurt to do like the Bessie 1-1 or the Klondike. It won't make any difference at this point. But okay, and that's something we clarified in an earlier video. Okay, because the parity separation has already taken place with this up jog random flip of 1/2. Okay, now, so what do we do from here? Ask the spectator if they want to flip the packet over, work from the other side. Well, that's true. See, maybe that should have been, sorry, step, bring it back on the camera. Step 11 could have been done at any point. Honestly, at any point anywhere in this entire performance, because 2 cycles, mirrored structures, AMPs are invariant under packet reversal, and also the Hummer sequence or the Hummer mixing is essentially invariant under packet flips. So sorry about that. That could have been should have been earlier. Oh, no, wait, sorry. That's true. What I just told you is true. That is true. But I had forgotten the purpose of this, having it here. The purpose is we're now giving them the illusion of kind of making or breaking this performance. Because right now we're saying, okay, we can work with the packet as is, or I can flip it over and work from the other side. And maybe in hindsight they'll think, oh man, if I had chosen the other way, it wouldn't have worked. Well, it would have actually. So I apologize. This can be done at any point, the whole thing, but here it's just giving the illusion that they have one final, very, very important choice to make. And so maybe they flip it, okay? And you can even groan like, oh, okay, I hope that doesn't ruin things. Well, it won't. It won't ruin anything, okay? So let's put those out. So, and then you bring out your written prediction that says, to find the answer you seek, add the card values of the up-facing cards. Okay, so what do we have here? 9 plus 5 is 14, plus 3 is 17, plus 8 is 25, plus 11 is 36, 36 plus 6 is 42. 42 is the answer to life, the universe, and everything, okay? Just type it into Google and all-knowing Google will tell you that that's the case. Okay, there you go. So that is just one of a near infinite number of different ways to use the information about what happens when you Hummer shuffle a 2-cycle. And here is a 2-cycle in which each cycle is of even length. Okay. We'll look at odd length next, as you might imagine. Okay, so given a 2-cycle where the cycle length is odd now, something different happens. Okay, something different happens. And you would probably expect that that would be the case. Okay? So let me go ahead and pull out one that we can use. Okay, so here we have a 2-cycle of the type mentioned here. We need an odd cycle length, which we have. We have a cycle length of 3. Okay, so let's go ahead and just quickly demonstrate this. So right now we have a 2-cycle. Okay, so what are some things you can do, with a 2-cycle? Why don't we go ahead? We can do a 50% coating. That would work just fine. We can go ahead and do an LR shuffle. You can do as many of those as you like. We can also do a Klondike. In fact, we can Klondike into pairs, give the spectator the choice. How do you want to stack these? That's just fine. And then we can do what's called a random LR. So this is where you go 1, 2. Instead of necessarily putting the next one there, you can give the spectator there. You have to build at one level at a time. Where do you want this one? There now. Okay, very good. It's back to a 2-cycle. Anyway, you can mix this almost forever using the hidden structures diagram. And so there we are. We're back to a 2-cycle with odd cycle length. Okay, so now we're going to Hummer shuffle this. Random cut, flip 2. I always seem to do the flipping first. Okay, random cut, flip 2. Maybe we'll flip 4 this time. Random cut, flip 2. You can actually do a table if you like. Spectator can kind of decide how to stack and flip these. That's just fine. You can do odd size coats, of course. There's a whole list of things that we showed you earlier that you can do. Now, we can do a PR. We can do PR shuffles as well. Why don't we do that this time? Because we didn't do it last time. So why don't we do one of these kind of fun ones down here. We'll do a down under, right there, if you can see it. Down, under, down, under, down, under, down, under, down, and then put the last one. We can actually follow that up with something called the Bessie 1-1. This is what we do here. Bessie 1-1, you take 1 from the top, 1 from the bottom, 1 from the top, 1 from the bottom, 1 from the top, 1 from the bottom. Okay? So that will preserve the essential Hummer structure of our packet. And at this point, we can perform a parity separation procedure. So why don't we just do the left, right, and then you can randomly flip and stack these. That's great. And so the claim is that we will get one complete cycle set of values, of 3 values, facing the opposite way to another complete cycle set of values. And we can see that that's the case. Now, it won't be that these all come from the same cycle as you can see right here. Okay, we can't guarantee that. But depending on how you structure the packet, boy, you can take advantage of the fact that you know that this kind of structure will result after all of this mixing and all of these random choices made by the spectator. That's the important thing. And it's only because of symmetry everywhere and everything, virtually everything we do in the hidden structures course that I've taught you, and also within the Hummer shuffling, there's symmetry just at every turn, okay? So it gives us a fair amount of predictability of what the ending structure will look like. Now for this one, I don't think I came up with, it wouldn't be hard to do, it's just that I don't want this video to be too long. I didn't come up with a separate application of that. That's something that I'm sure the viewer could do, just giving it a little bit of thought. Okay, so what that has done so far is going back to this. Remember, we're going from hidden structures and then we're taking it into the world of Hummerism. Okay, so we've done 2 cycles. Let's do mirrored structures. Okay, so as we look at mirrored structures and AMP structures and their relationship to Hummer shuffling, you're going to find that you may be able to anticipate the kinds of outcomes that we'll get. And it's for the simple reason that you can use what you've learned about taking 2 cycles into the realm of Hummerism, and the fact that 2 cycles are closely related to mirrored structures, which are closely related to AMP structures. Okay? So you might be able to actually kind of see this ahead of time, which is wonderful. Okay? So here, there's no restriction, which is really nice for the cycle length. So I just chose a cycle length of 5 just for variety. Okay, so we can use the hidden structure mappings, shuffles, mixing routines to mix this. Okay, so as always, we can do as many LR shuffles as we like. One that I haven't been using much, but we can use it here, is you can actually do a ferrule shuffle, an in or an out, and that's where you break the packet in half and then you perfectly interlace them. That preserves mirrored structures also. Let's see, we can do 2 identical overcoats. So if the person's name is Robert, let's say, R-O-B-E-R-T, that's Robert, put the rest on top, R-O-B-E-R-T, Robert, that actually preserves mirrored structures too, 2 identical overcoats. Okay, well, that's probably enough. So you mix this probably more than the spectator can handle in terms of their patience for the whole process. But now the Hummer shuffle is so different that they normally kind of wake up. They go, oh, that's different. So we can do a random cut, flip 2, random cut, flip 2. I always seem to do that. Random cut, flip 2, random cut, flip 2. Now, if you think about it, I've been handling the cards, okay? So the spectator might think, well, you're just doing something special with the cards. Well, yes and no, okay? So if you do a table Hummer shuffle next, they're free to flip and stack these however they like. Another classic way to do it, which is very effective, is to give the spectator choices. I can set this and leave it as it is or flip it over. What would you like? Flipped over? Very good. Leave or flip? Leave. Flip. Okay. Flip again. Okay. Leave that one. And then you can even go through and do any even numbers. So you can do 4, leave or flip. Flip. Leave. And then flip. Okay. So that gives them some choices. And then you can, once again, here, if I were you, I would be, I would use these sparingly, but you can do any of these, actually. So you can actually do an LR shuffle. You just have to follow it with a Klondike. Okay? So you have to realize that this is a Hummer packet now. This isn't mirrored or 2 cycle or AMP. That's gone. That's destroyed. So it's a Hummer packet. Okay, so you have to treat it as a Hummer packet. Okay, so any of these can be done and safely, protect this. I should also always remember that, that we can flip the packet over at any stage and work from the other side, and that's another powerful choice that the spectator makes that ends up making no difference. Okay. So that's another wonderful example of symmetry. Symmetry means you can have a distinction without a difference. Flipping this over is different. It's a different, it's distinct from. It's distinct from not flipping it. But in the end, it makes no difference to the structure type. Okay, so we've done that, and then we can do one parity separation procedure. And so why don't we do, we can just do, why don't we do the up jog? But this time we won't follow it with any other, we don't need to. So if we randomly stack and flip, that on our list is actually one of our parity separation procedures. Right there, up jog, random flip. Okay, so now what should be the case, if I haven't messed up here, we should have one representative, or maybe stated here a little better, we have one complete set of 5, that's in there, 5 unique mirrored values facing the opposite way to another complete set of distinct mirrored values. Okay, so what that means is we should have an ace, 2, 3, and a 4, and a 5. Sorry, we have 5 things. So ace through 5 should be facing each way. And as you can see, we don't know exactly what cycle they came from. We can't know that. We cannot know that. You have to remember that the Hummer shuffle achieves every possible ordering of the cards. But think about it. The fact that we still know at the end that we have a complete set of these mirrored values is amazing. That we know an ace will be facing one way and the other ace will be facing the other way. The same thing with the 2, 3, 4, and 5. So it's just incredible, actually. Okay, so anyway, that is a demonstration of what happens when you work with a mirrored structure, and mix it to the convincing of the spectator, convert it back to mirrored. It needs to be mirrored for this result to apply, and then you can Hummer shuffle it however you like. And of course, you need a parity separation procedure at the end, and you'll get this kind of result. Okay, so let's quickly apply it to, this particular outcome probably won't mean a lot necessarily to the spectator. So you have to dress it up a bit to make it more interesting. So let's take a look at an application. This involves just 8 cards. So here, I'll go ahead and set those up. Okay, I've set up a mirrored packet according to the structure here. It's mirrored relative to card suit. Okay, club, heart, spades, diamond. So here we go. So we have a mirrored structure. Now we can mix this by converting it to a 2-cycle or an ANP, and just give the spectator so many choices as to what's going on. Okay? Now, I'm not going to take the time to convert it to an AMP and a 2-cycle and so forth. You can do that using the skills that I've shown you earlier. But we'll go ahead and do a thorough Hummer shuffle. So random cut, flip 2, random cut, flip 2, random cut, flip 2. And now, as you recall, we can put these out, for the spectator to decide how to stack or flip any of these. We can also do the 2 at a time. You want them flipped. Great. Leave, flip. Very good. You can deal out you can coat an odd number of cards, and in fact, you can do any of these shuffles here. Any of these can be done. Now don't do all of them, or your spectator will fall asleep. But any of these can be done to this packet, and it will not undermine it. And I also keep forgetting to tell people that at any point, the spectator can say flip, and you can work from the packet. You work the packet from the other side, okay? Okay, so now we will perform any one of our parity separation procedures. Now, we can do one that we haven't actually done yet. So you can actually put out the cards like this. They fit. And then you can have the spectator, if they enjoy folding things. This is kind of a book that's folded in a funny way. They can fold all of these together. Some will be mesmerized by that. Okay, that's a folding procedure. That is a parity separation procedure, and it will allow us to finish in the way that we want. So put out the cards, and the claim is there will be one complete set of clubs, hearts, spades, diamonds facing one way, and another complete set of clubs, hearts, spades, diamonds facing the other way. And we can see that that's the case. Clubs, hearts, spades, diamonds. And same thing on the other side. Okay, so that's just kind of a simple application of the fact that if you have a mirrored structure and then you Hummer shuffle it, you know quite a bit about the ending configuration of the cards relative to what's face up or what's face down. Okay, now let's get on to AMP structures. So those are next. Okay, so we have an AMP here. If you notice, there's no restriction on the value of n, so this can be even or odd. So I've chosen a total of 14 cards to work with. Now, we can mix this using the hidden structures diagram, but eventually you need to bring it back to an AMP for this to apply down here, okay? So let's see, as a AMP, let me show you. Now, of course, you know that we can do an LR shuffle, and that converts it to a 2-cycle, but we can also do an R LR. Well, R stands for random, and it's random up to a point. So you can do, as long as you build up one level at a time, this next one can actually go on either pile. So you can give the spectator the choice, okay? Now, from the spectator's point of view, they're probably pretty confident they've destroyed any structure that you maybe had in mind to preserve. Now, they haven't done that because it's an AMP. You have two aces, it doesn't matter where the ace goes, it doesn't matter where the 2 goes, right? So this is a 2-cycle relative to card value, right? So here we go. Whoops, sorry about that. 7, 7, 6, 6, 5, 5, and so forth. Okay, well, since it's a 2-cycle, we can do, Charlier shuffles. One that we haven't been using lately is just an ordinary 50% coating, if you like. Now, this can be really helpful if for whatever reason dealing out the 7 cards has some kind of meaning. So if the number of letters in their name have 7, there's 7 letters in their name or something. And a lot of people see 7 as a lucky number, so you can deal that out and go, oh, this is going to give us the luck that we need for this. Which is kind of ironic because the next application is called the lucky face card. Okay. So let's see, what is this? This is now it's a mirrored structure. And once it's mirrored, of course, you can do, LR shuffles, use the stay stack principle. You can do 2 identical overcoats, you can do up jogs, you can do the Pharaoh, and so forth. But let's get it back to an AMP. Well, since it's mirrored, let's just get there the fastest way, which is the Klondike. Okay, so now it's going to be back to some sort of mirrored structure, right? In pairs, they're going to be of the same value. Okay, so what we can do now is do a random cut, of course, flip 2. Now, it might be smart for that you know, if you can kind of keep track at first, you know, when we say, whoops, random got flipped to. For the first cut here, it might be good to do an even cut. Excuse me, an odd cut. Because if you do an even cut, you're going to flip over 2 cards of the same value. You know, it's going to be, what is that? But as you begin to mix this, every ordering of the cards is achievable by way of a Hummer shuffle. So it won't take very many of these before every vestige of an AMP is gone. Maybe we'll flip 4. Hopefully I did 4. 4 again, and so forth. Okay, and then you can put them on the table. They can randomly stack and flip, or you can give them the choice, leave, flip, that kind of thing. And then on top of that, as always, you can do any of the PR shuffles. And as a reminder, these respect alternating packets relative to card orientation. Okay, so that's why they can be used safely in a Hummer routine. And then at the very end, we just need to do a parity separation procedure. And so we could do a folding procedure if we wanted to. So we can do, you know, some kind of folding procedure. Now, what's nice about the folding procedure is that if you notice, I didn't deal out, I didn't finish, right, an entire set of 4, because I can't, because there are 14 cards. But it doesn't, if I put out an even number, that's the key, an even number of piles, it won't affect the fact that this is going to be a parity separation procedure, okay? And so whatever conclusion we have down here is going to apply just fine. Okay, just make sure all the cards are out. Okay, so what's the conclusion? There'll be one complete set of n is 7 in our case. Sorry, that's off the silly screen. 7 unique values from each of the pairs. Well, what that means is we'll have a 1, 2, 3, 4, 5, 6, 7. Now, we won't know the order nor the color, right? That is beyond our control. But we will have one of each value. Boy, think about how you could use that information, okay? If you're kind of clever and thinking, okay, how can I use this ending structure to come up with something surprising, okay? And of course, it will be the same thing. It has to be on the other side. You're going to have ace through 7 in some order. Okay, so let's do an application. We're getting close to the end of the video here. So objective for this, it's called a lucky face card. So objective, earn the highest score. You and the spectator each choose a lucky face card. Okay, well, one lucky card that a lot of people gravitate towards is actually the Queen of Hearts, and then maybe another one could be a King of Clubs. Okay, so there we go. So maybe they choose that one, and then I choose this one. Okay. Now, the spectator can freely select 3 pairs of red numbered cards and then 2 pairs of black numbered cards. So these pairs are randomly stacked together and then thoroughly mixed, face up, face down. Okay, so what we do is, so these 2 go together. These are lucky. These are lucky ones, right? Okay, so these can be, in fact, what you can do, which, once the spectator has freely chosen their cards and you have freely chosen your lucky card, and they've chosen their lucky face cards, excuse me, the spectator can now freely stack these however they like. Okay, well, just think about what this is. It's an AMP, right? Okay, so let's talk about the scoring. The value of the number, so we're kind of looking ahead here to the end. So we're going to be mixing these cards face up, face down. The value of the number cards facing the same way as the player's lucky face card will be totaled. Then the number of red cards among these numbered cards, so not the face cards, just the numbered cards, is added to this total to give the player's final score. The player with the highest score wins. Okay, so here's a suggested mixing sequence that constitutes just one of many, many, many possibilities for mixing these cards. So it's beginning as an AMP. So we're in the world of hidden structures. We're not dealing with Hummerism yet. Okay, so this is an AMP. So hidden structures mixing after completing setup. Blah, 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 blah. Okay, so I just give. I don't know if I needed to have listed those, but I have. The spectator can decide how to stack those. You can do a Charlier. Something else you can do is have the spectator just randomly cut the cards. Okay. Now there is some danger in that, because if they drop the cards everywhere, all's lost. You'll have to start over. But if you can trust them to actually cut the cards correctly, that's fine. Okay, now here is one that I don't really know if I have brought it up in any of the videos in this particular series. And even my students aren't super familiar with this one yet. It's an automorphism on 2 cycles that I discovered. Okay, so really anyone who has studied the basics of my course, they would know that this is a 2 cycle. They would be utterly mystified by this. You don't LR shuffle. We have never LR shuffled a 2 cycle. It destroys it. You can't. But what I discovered was if you pair it with a Klondike, it does constitute an automorphism on 2 cycles. Okay, so we can do left, right, with random stacking decided by the spectator, maybe right on left, it doesn't matter. Now, if you follow it up with a Klondike, it remains a 2 cycle. Okay, so that is a very, very nice automorphism on 2 cycles. Okay, now there is another shuffle here. So it's probably good I've done this, because I'm introducing newer shuffles that I have discovered just in recent months, actually. The alternate Klondike ends up being an incredibly powerful shuffle. Because guess what? It does a full cycle of our mirrored structure triplet. So we have two cycles mirrored structures AMPs, right? The alternate Klondike just goes round and round. Goes from one structure type to another. Okay, so let's go ahead and do it. So we're going to do a left, right, alternate into 2 piles, alternate Klondike into 2 piles, random stacking. Okay, so let's just show you that it's given us a mirrored structure. Okay, well, it's a little bit harder to see that it's mirrored here, but okay, so look, the face cards are mirrored, the 10s are mirrored, the 3s, the 6s, the 7s, and the 4s. Isn't that amazing? That's amazing. Okay, and now we can do use the stay stack. So maybe it looks like I've gone with 4 piles of 3. Why am I saying 3? I guess I'm saying 3. Okay, and then these can be stacked from left to right, right to left. you can actually do this kind of hopping thing too. So I could go like that, but this one needs to go here, and then random stack. Okay, so if that's one that you want to play with and kind of use a transparent structure and kind of test that and see what's going on as to why that actually does preserve mirrored structures, because it does. And maybe I'll just show you really fast. See the 10s, the 4s, the 3s, and so forth. Okay, and then we could do an even up jog. Okay, there you go. Now, I suppose if you do these quickly, and then random stack, if you do these quickly enough, and then you're giving the spectator choices along the way, it need not take forever. And then you can actually do a Charlie A1. If you remember, that's where you push just one card over from the top, and then bottom to top, top to bottom, bottom to top. And you may recall that this is actually an automorphism on 2 cycles, mirrored structures, and AMPs. In fact, it's one of the few automorphisms, it's, one of the few shuffles that's an automorphism for all 3 structure types, which is really nice. Okay, and I guess I should qualify that. For the AMP, you need to have 4N cards, which we do, right? Because we have 12 cards here, so I have to be careful. But no restriction on the mirror. Okay, and then here's a fun way, a way that I don't think I've shown you to get back to an AMP. We often do a Klondike, okay? But what you can do is a reverse LR. Well, and with random stacking. It's just amazing, as you'll see. Okay, so reverse LR. So what that means is you deal, okay, so I'm going to deal out the cycle length. Total cycle length is 6. And now a normal, like left or right, you'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? But with this LR negative R, it just means you go in reverse. Well, think about what that's doing. This is what we call a DMP. These are distinct mirrored pairs, right? And now, right? And so now you can allow random stacking. So you said, tell the spectator, which one do you want me to pick up first? This one? Okay, that one? This one? Are you sure? Oh, you want this one instead? That's fine. This one? That one now? Okay, very good. And then this one. In the mind of the spectator, all's lost for the performer. If they were hoping for some particular order or outcome, the spectator just destroyed it, okay? But they haven't, because AMPs are impervious to that kind of stacking. They're not affected by it. Okay, now finally we get to the Hummer shuffle. Okay, so you can do random. Probably should have followed what I said, how you do it even. You do an odd cut at first. Otherwise it's going to be a little transparent as to what's going on. Now that's not going to be so bad, I guess. Let's see, I get lucky? Yes, okay. So you do have to be a little careful at first, but then these start to truly get randomized. I'm going to flip 4. And then I'll flip, and just 2, that's fine. Then you can put them out, as always, and the spectator can decide how to randomly stack and flip those. So any of the Hummer shuffles, including, not sure why I listed it here, not on the other pages. Here's all of the PR shuffles you can perform, and it won't hurt the Hummer structure here. Okay, so I'll have you just look at that. Okay, and now perform one. I'm not sure why I didn't do this on the other ones. Perform one parity separation procedure. Okay, so why don't we do one of these? Like this one here is kind of funny. Okay, so down, under. So down, under, down, under, down, under, down, under, down, under, down. Under, down, under, down, under, down, under, down, under, down, and then last one goes on top. Okay, but you can't stop there, right? You can't stop there. So you're going to have to follow it up with something, okay? So here we will need to follow it up with a ferro, right here, this one. Now, just for the record, and I noticed this earlier while recording, this is a goof. That's a goof. In fact, I used it in the middle of our video today, and as I was performing it, I was thinking, that doesn't work. What the heck? Why do I have that there? This is a standalone, doesn't work. So I apologize for that. So that's actually a goof back here. Okay? So I apologize for that. As a standalone, you have to pair it. That won't work. Well, maybe I'll just remind you of what this ferro F is. You might be kind of puzzled as to what is that thing anyway. Okay, so we have done a down under. Now we can follow it with, so a ferro flip is the following. You have to break off half the cards, which is 6. And then, well, okay, let me put it back for a second because I need to hold it from a different position. Okay, so there's 6. So for a ferro F, you pull them off and flip them. Technically, I could have flipped the other side instead. And now you simply just do a perfect interlacing of the cards. Get up there. Come on, king. Get up there. And then that constitutes a parity separation procedure, and you're fine. So after completing this, calculate each player's final score. The 2 players, guess what? And you could write this as a prediction. It always ends in a tie. Always, always. It always ends in a tie. So if you have somebody who's a sore loser, this is a good little routine because they won't lose. They won't win either, I guess. Maybe that's bad. So let me just show you that. So if you remember, how did the scoring work? Well, how it worked was whichever number cards are face up, along with my special lucky face card, I add those up. Well, you can kind of see what's going to happen already. Look, we have 3 distinct red cards. We started with 3 pairs, and then 2 distinct pairs of black cards. Well, you're going to get the same score, right? It's going to be exactly the same because you have the same values facing up, along with the individual's lucky face card. Okay, so you're going to get an exact tie. Now, for somebody to, after they've seen all of the mixing that's gone on and all of the choices that they freely made, for this to come out in this way is just going to be completely inexplicable. I mean, it's going to be miraculous. Like, how is that possible? And part of it is that they'll kind of go back in time and go, oh, if I had only chosen to stack left to right or right to left, it wouldn't have worked. Darn it. I wish I could go back in time and change my decision. It wouldn't have made any difference. Because of what? Symmetry. The symmetry of what we're doing. So doing it from left to right, or any of the choices we gave them, it wouldn't matter what they chose because of symmetry. So anyway, that's the a performance for an AMP. And then I just point out that you could Alternatively, I mean, this is the thing to do if you're going to really become a true mathematical card magician. You're going to have to think through, okay, maybe you have a certain routine, like I've just shown you this one. It ends in a tie. Great. And then you have to think through, okay, how could I do a variation where it doesn't end in a tie? Somebody wins. Well, I don't think it'll take much thought for you to realize that if we had allowed, maybe in the written prediction, so you don't tell them this ahead of time, that not only will the up-facing number cards be added up, but you're also going to add up, oh, I guess I forgot to do that. I apologize for that. We were supposed to have added up the number of red number cards and add that to our total. Okay, well, both the player and the performer would end in a tie nonetheless. Okay, sorry about that. But if you had written a prediction as to kind of how things would need to be done at the end, and the player happened to choose a red card, and then you intentionally chose a black face card, which I did, you know that they will win by 1 point, because the values of the up-facing numbered cards will match on both sides, but they'll have one more up-facing red card if you're allowing all of the red cards to count as one because they're red, so additional points being added. So you would lose by 1. So anyway, that's all this is saying. If one of the players at the beginning of the lucky face card routine happens to choose a red face card and the other black, and if all the number cards are red, including the face cards are added to the total, then the person who chose the red face card will win by 1 point. Okay, very good. Okay, so that is the end of the video that shows you this direction. Okay, so anyway, so please join me for the final video. We're going to reverse this. Hope you join me for the final video in this series.